A very good evening to all of you at the centers which are connected. I am very glad to see that even though this is one of the later parts of the semester, the later interactions in the semester, we do have several centers which are online right now, and I do hope to have a very active interaction with all of you. So without further ado, then let's take center by center and proceed to invite questions. Let's start with Samrat Ashok Technological University. Start interaction. Oh, Samrat Ashok has no video. Let's go to College of Engineering, Pune. Good evening.
Good evening, sir.
Good evening.
Yes, sir. Yes, sir. So my question is that what is the difference between this? Why FIR system or FIR filter is unconditionally stable?
Okay, so why is the finite impulse response filter unconditionally stable? Now I can answer that, it's very easy. You see, what is the impulse response of an FIR filter? It's finite in length. Is that right?
Finite event, yes.
So
Yes, sir.
if each of the samples is finite, which they have to be, the absolute sum of the impulse response has to be finite.
Yes, sir.
Summation mod Hn over all n has no choice but to be finite, because it is upper bounded by the number of samples multiplied by the maximum magnitude of any of the samples. So if the absolute sum of the impulse response is finite, the system is unconditionally stable.
Okay. Yes.
Alright. So is it clear?
Yes, sir. Yes, sir.
Alright. So any other questions from you?
No, sir.
Alright. Okay, let's go to the next institute then, Amrita Vishwa Vidyapeetham. Yes. A very good evening to you, Amrita Vishwa Vidyapeetham in Kerala, Coimbatore. Tamil Nadu, yeah. So very good evening, Amrita Vishwa Vidyapeetham in Coimbatore. So do you have some questions? Okay, yes, good evening.
Evening.
Yeah, so can you introduce yourselves and ask questions?
Evening, sir.
Good evening.
Sir, I am J. Aravind of Amrita Vishwa Vidyapeetham Center.
Yes, good evening, Professor Arvind.
Evening, sir. Audio track is not hear your voice, sir.
Oh, okay. Can you hear me now? Okay. Okay, so we'll come back to you then. Let's go to Banari Aman Institute of Technology. So good evening at Banari Aman Institute of Technology. This is at Erode, Tamil Nadu. Okay, there doesn't seem to be anybody at Banari Aman. So let's go to the Institute of Road and Transport Technology. It's not publishing video. Okay, let's go to NMIMS Shirpur, Dure. Taking some time to come. So, a very good evening to you, NMIMS Shirpur. Today, bandwidth very low. So, very good evening to you. Do you have questions?
Good evening, sir.
Good evening.
Good evening, sir. Professor in computer.
Yes,
Sir, my
please go on.
question is that.
Yes.
Yes, sir. My question is that how to.
Yeah, please go on. Okay, so we'll come back to you later. Let's go to NIT Agartala. No, they're not publishing. Let's go to Tyagaraja College of Engineering, Madurai. Good evening.
Good evening, sir.
Good evening.
Myself is Vel Murugan.
Yes, Professor Velmurugan. Good evening.
I have two doubts, sir.
Yes, please.
How to find the discrete time Fourier transform for a unit step signal? Unit
Okay.
step signal is not an absolute summable one, sir. But in
Yes.
book they have given an approximate answer for that one. In in OpenGame.
Yeah. You see, for
So
the unit step, strictly there is no discrete time transform, because it's the summation for the discrete time Fourier transform would not converge strictly. It would not converge for all frequencies. There would be a problem at the 0 frequency. For the other frequencies you can still think of its conversions, but at 0 frequency it does not converge. So, in fact, you need to deal with this unit step, in fact, whether it is in continuous or discrete time, you need to play a clever trick of excluding the point z equal to 1 from the contour by encircling it. When you take the inverse discrete time Fourier transform, what you actually do is to integrate along the unit circle, isn't it? You are essentially evaluating the z transform on the unit circle, but then in the inverse transform you must then choose a contour which excludes the point z equal to 1, a very small radius around the point z equal to 1, and therefore what happens is you get an impulse. So, you get an impulse located around omega equal to 0, plus of course you get the regular expression where you put z equal to e raised to the power j omega. So, you get 1 by 1 minus, in fact I will write that down. Yeah. So, you see, if you think about it, how do you evaluate an inverse? So, the z transform is very clear. So, z transform of a unit step is summation n going from 0 to infinity 1 times z raised to the power minus n. That is 1 by 1 minus z inverse. That is very clear, but the region of convergence is mod z greater than 1. Is that right? So, really mod z equal to 1 is not included, but you can take, you see, now how do you invert the z transform? You can invert the z transform by integrating around a closed contour in the region of convergence, C in the ROC. Xz times z to the power n minus 1 dz. All that is all right. However, if you look at the region of convergence now, let us draw it. This is the circle, this is the unit circle. And now the contour that you need to choose is something like this. You have to exclude, there is a pole here, you have to exclude that pole, and you choose a contour which runs around that pole. So, you can choose a contour like this, go around the unit circle, but then encircle this very gently and use that idea to invert the Z transform. Now, when you do that, you will find that the inverse Z transform when evaluated on the unit circle except for Z equal to 1 is the standard thing. It is 1 by 1 minus e raised to the power. So, you have 1 by 1 minus e raised to the power minus j omega for omega other than 0. But you also need to include an impulse at omega equal to 0 to take care of the encirclement. To take care of encirclement. So, you have an impulse at z equal to at omega equal to 0, and you have the regular inverse Z transform, or rather you have the Z transform with Z replaced by e raised to the power minus j omega, but that part is valid for omega other than 0. Is that all right? That is how. So, you have to play this trick of encircling omega at the point z equal to 1 when inverting the Z transform.
Okay. The next question, sir.
Yes.
How to find the ROC for this problem? 1 by 2 to the power n u of n
Okay.
minus 1 by 4 to the power n u of minus n minus 1.
Okay. So,
how to find the ROC?
Yeah. So, you see,
one is causal, another one is anti-causal.
And anti-causal, right. So, see the 1 by 4, now it has to be the intersection of the ROCs corresponding to each of the terms. So, for half to the power of n un,
here no intersection will be here.
So, if there is no intersection
in this problem, that is 1 by 2.
Right. So, therefore, it has to be the intersection. So, the intersection is null, there is no, that means the Z transform does not exist. The Z transform does not have to exist for all sequences. So, in this case there is no intersection because it is 1 by 4. So, it has to be mod Z, no, but mod Z less than 4. So, it is all right. See, let us be clear, mod Z less than 1/4, I am sorry. So, mod Z less than 1/4 and mod Z greater than 4, there is no intersection. So, therefore, this has no Z transform. There is no region of the Z plane where the Z transform converges, isn't it? There is no point in the Z plane at which the Z transform
this problem is summable one, sir.
1 by 4 to the power n u of minus n minus 1 is not summable. So, 4 to the power of n u minus n minus 1 would have been summable, but 1 by 4 to the, see,
yes,
it is the left sided component, not the right side, remember. 1 by 4 to the power of n u minus n minus 1 grows exponentially to the left. It starts with 1 by 4 at n equal to minus 1 and it continues as 1 by, not 1 by, it starts as 1 by 4 inverse, that is 4, and then it becomes 4 squared, 4 cubed as you go to the left, is it not? It increases exponentially, to the left. So, since it increases exponentially, you have to curb it by bringing the region of convergence to within mod z equal to 1 by 4. So, the region of convergence for that part would be mod z less than 1 by 4, but for the other term you need mod z greater than half. There is no intersection between them, right. So, this says this sequence has no z transform.
But individually it is summable one, sir?
No, individually also they are not summable. So, the left sided part is not summable, the right sided part is summable, but the left sided one is not summable.
But we are saying there is an ROC mod z less than 1 by 4.
Yes. So, what it means is you have to multiply, see it is growing exponentially at the rate of 4. So, when you are, so by putting an ROC, see what do you mean by a region of convergence? You want to multiply it by an even stronger exponential sequence, an exponential sequence that decays even faster, isn't it? That is what you do when you choose. Let's see, for example, let us take an example. Let's take the next page. Let's take the part corresponding to 1 by 4 to the power of n u of minus n minus 1. Is this what you want?
Yes, sir.
So, this is, let us see the sequence. How does it look? At minus 1 it takes the value 1 by 4 inverse, that is 4, and then it takes the value 4 squared at minus 2, 4 cubed and so on. So, it grows exponentially. Now, I want to find its z transform. So, I do 1 by 4 to the power n, z to the power minus n, summation n going from minus infinity to minus 1. Now, here this can be written, of course, you can invert the sign on n and write n equal to 1 to infinity, but 1 by 4 to the power minus n and z to the power n. Now, let us take for example z equal to 1 by 8. So, what is the situation we have here? Summation n equal to 1 to infinity 1 by 4 to the power minus n times 1 by 8 to the power n, which is summation n going from 1 to infinity 4 by 8 to the power n, which is summable. So, therefore, the z transform converges, for example, at z equal to 1 by 8, which is in the region mod z less than 1 by 4, right. So, it is not, it is an exponentially growing sequence, but it is, I think if you have listened to my lecture in the z transform, when I introduced the z transform, I told you it is, as far as the z transform is concerned, you have to think about how you can tame a lion or a tiger in addition to taming just a dog or a horse, isn't it? To tame a lion or a tiger, you need to put it in a cage which is stronger than the lion or the tiger. So, here you are putting that sequence in a cage which is stronger than the sequence, then it can be z transformed.
Thank you, sir. Thank you.
All right.
Thanks, sir.
So, any other questions?
No, sir. No, sir. Thank you, sir.
All right. So, now we have University BDT College of Engineering. So, there are no participants there. Let us go to Geetam University, Hyderabad. No, they are not publishing. Let us go to Amity University, Haryana. A very good evening to you.
Good evening, sir.
Good evening. Yeah, please go on. Please ask your questions.
Sir, we don't have any question.
Okay, you don't have any questions. Anything that you want to discuss in this? Any feedback that you want to give, or anything that you want to discuss in this interaction?
No discussion, sir.
Okay, thank you. In that case, let us go to uh, NIT Agartala. Are they online now? Yes. A very good evening to you, NIT Agartala. You will have to turn your audio on, please.
Audible, sir?
Yes, good evening. Yes.
Sir, actually the thing is that our students are having their exams on 2nd, 3rd and 4th December, end term examination. And also the final quiz is slated on those days, scheduled on those days.
Okay.
So can it be extended for a day so that our students
Yes,
can
certainly. In fact,
attempt the test?
we are planning to extend the date of the semester and examination in the online course so that you can accommodate your individual schedules. So we shall be extending that date. Yes.
Sir, there is a question regarding sampling.
Okay.
Something in Silo. So regarding zero order hold, why we are calling this zero order hold?
Yeah, the term zero order hold refers to the polynomial degree with which you are interpolating. So, in a zero order hold, you are holding the value until the next value comes constant. So, we are using a polynomial of degree 0 to interpolate. So, it is a constant has been maintained. Now, if it is a first order hold, it makes a linear interpolator. So, it uses a polynomial of degree 1. So, 0 order, first order, the order refers to the order of the polynomial used for interpolation.
There is one more thing, like zero order hold seems to be more practically realizable compared to normal filtering, low pass filtering.
That, well, it depends on,
So
okay, it depends on what you see. The ideal low pass filter anyway cannot be realized, but normal low pass filtering, for example, if you are doing RC filtering, then RC filtering may be as easy or maybe easier than a zero order hold, because for a zero order hold you require active elements also, whereas in an RC filter you do not need any active elements. So, it depends on what low pass filter one is talking about, the ideal one or the non ideal one.
thank you.
So, any other questions?
No, sir. Thank you.
Okay, thank you. So, then we will go on to NMS, IMS, MS, MPS, TME, Shirpur. So, Shirpur, are you online? Okay, so you raised your hand. So,
Good evening, sir.
good evening. Bandwidth. We can't hear you, Shirpur. Are you on? Yes. Yes, go on, please. Yes, NMIMS Shirpur, are you online? Alright, we will come back to you. Let us try Institute of Road and Transport Technology. No, they are not publishing the video. Right. University BDT, Tyagaraja College is done. So, Shirpur is the only one left. Shirpur, then are you online? Can we hear you? Alright, so if any of the centers has a question, then you could raise your hand, please. Raise your hand so we can then go to you. Yes, there is a question from Tyagaraja College. Yes, good evening.
Sir, good evening, sir.
Good evening, yes.
So based upon poles and zero location, we are telling whether the system is low pass filter or a high pass filter.
Okay.
How to say based upon the pole and zero location, it is a band pass filter or band stop filter.
Okay. So, what would you expect in a band pass or band stop? You would want nulls to be present at 0 and infinite. If you are talking about an analog filter, there would be zeros at 0, there would be nulls at the 0 frequency. If it is a band pass filter, you would need a null at 0 frequency and a null at infinity, right. So, 0 at infinity, so to speak, and somewhere, and there needs to be a pole somewhere in between where you want to have a high response. But that pole of course can't be on the imaginary axis, it will be a little inside the left side of the S plane, but near the frequency where you want a maximum. Is that right? So, you need a null at 0 and a null at infinity, and you need a pole somewhere close to the frequency where you want to have a peak. And in fact, if you want to have a higher order band pass filter, then you need to concentrate a few poles in that region. So, you can strengthen by increasing the order of the pole or the multiplicity of the pole, or you could increase by putting poles near that frequency where you want a maximum.
Okay.
That is the broad idea, but one must look at specific cases and then that will be even clearer. If you take an RC circuit for example, you can work out its pole 0 locations, the RLC circuit, I am sorry. If I take, let me take an example of an RLC circuit. So, for an RLC circuit, if I choose so I have a simple, let me take the case of resistor being the output device. So, I can write down the system function here, the input voltage and the output voltage. So, I can write down the system function. So, RCS divided by LCS squared plus RCS plus 1. You can divide numerator and denominator by, you have R by L S, S squared plus R by L S plus 1 by L C. Now, you can see, you can factorize, now one thing is you can see that this has a null at 0, because at S equal to 0 it takes the value 0, it also has a null at S tending to infinity, because as S tends to infinity the denominator grows faster than the numerator, so therefore, it has a null as S tends to infinity. Now, what about in between? Let us see where the poles lie. The poles lie at S is minus B plus, let me write it here. So, the poles lie at S equal to minus B plus minus root B squared minus 4AC by 2a. Now, here you notice that you know it again now you expect that this should satisfy certain conditions. So, the damping should be such that this should give you an imaginary value, otherwise it will not behave as a band pass. So, this it's now of course, here there is no problem. So, let us see what happens here. Where would these poles occur, right? You can actually plot them. No, I am sorry, b squared minus 4ac, right. Yeah, I think this is all right. Yeah, so in fact, now for the so what will happen in this case? You can now try and plot the poles in the S plane here and see what happens, right? Where do the poles lie here, right? Now, in fact, that also depends on the relative values of R, L and C. Is that right?
Yes, sir.
So, now you can take it further from here, look at draw the pole locations, but the idea is it reinforces the point where you expect, see, where will this have a maximum value? The maximum value of the system on the imaginary axis, the maximum value occurs at the resonant frequency here. So, you expect the pole to
Yes,
yeah,
sir.
you expect the pole to enhance the resonant frequency here. So, the presence of the pole actually enhances the resonant frequency. Is that right?
Yes, sir. Yes, sir. Thank you, sir.
All right. So, any other questions for any of the other centers?
No, sir.
Yeah,
No,
is there
sir.
any?
Thank you, sir.
Yeah, right. So, this is also an occasion for you to give any feedback that you wish. So, if any of the centers wish to give some feedback, they are most welcome to raise their hands. You can start with Tyagaraja College if you have any feedback or if you have any points of,
Sir, can you repeat the question, sir?
Yeah, I said that in addition to any technical questions, this will be the last interaction, live interaction before we conclude this semester's course. So,
Yes,
you can
sir.
also give any feedback that you wish to, live feedback if you wish to give. If there is anything that you would like to share with us in your experience
Feedback.
of running this course, you are welcome to share it, if there is something.
Sir, the interaction sections are very good, sir. You are very passionate to answer all the questions, and
Oh, thank you so much. So, I
we have
hope,
learned a lot of things, sir.
okay.
Um, but we have lateral entry students, sir, in third semester. They feel very difficult to learn this online course, sir.
I see. So, what
But
are
they
the,
have taken a lot of initiatives, sir.
okay,
That is, they are from polytechnic to direct second year.
okay,
So they feel first in the initial they feel it is very difficult, but after first internal, second internal, they pick up this course.
okay. So, can you also point to where they find difficulties?
In the initial stage, sir, because we started later only. That is 3 weeks later only we start this
Oh,
course. There is a 3 weeks gap, and students feel very difficult to catch this portions.
okay, okay. So, because you started
Yes.
late, there was a difficulty.
Yes, sir.
Okay.
Otherwise, it is good.
So, anything, any
Other
did you
challenging
find,
problem.
okay. Did you find some difficulty in terms of prior training? So, did the students have some difficulty in not having some prior background required for the course?
Yes, sir. They have not background in maths. That's a problem.
Oh, I see. So, they do not have adequate background in maths. So is there something that you will suggest to be done for that, to overcome that problem?
எப்படி overcome பண்ணலாம்? We have given extra training for them, sir. We have conducted several special coaching classes for them
Okay.
in the evening and as well as Saturday.
All right. So what are the topics on which we are trying to understand the common requirements? So what are the topics on which this kind of additional training needs to be given?
Basic mathematics only, sir. They have not strong in mathematics, so we have given integration and differentiation.
Calculus. College calculus.
Very basic mathematics only, sir.
All right.
Yes, sir.
All right.
And we have one more doubt, sir. How to see that student progress report
We'll
in our login, or we have to see this in student login?
We'll get back to you because I don't have the answer to that question right now. My technical staff is not here, but you can also pose the question. Sir, okay. You can also pose the question to the e-outreach, and they would get back to you, I believe.
Okay, sir. Okay.
Right?
Okay, sir. Okay, sir.
Yeah.
Okay, sir. Thank you, sir.
Thank you so much. Yes. Is there any other center which likes to give some feedback or would like to discuss some administrative points? Can you raise your hand? Yes, College of Engineering Pune wishes to say something. Yes, good evening. Yes.
Yes. So it was a very nice experience to learn signal science systems with other perspective from you. So I think it's a very good experience for all of us. And I would like to mention that this course which we have conducted from online had put the example how the internet communication technology can be used for the welfare of all the students from the remote places also. And I would like to congratulate the IIT Bombay team to handle this course very effectively throughout the semester. And yes, I think I mentioned here that yes, this particular initiative which has been taken by MHRD and IIT Bombay will definitely be helpful and will put some kind of footprint for the kind of thing how we can use all this technology to communicate the students from the remote places.
Very good. That's very nice to hear. In fact, we are also keen that IIT Bombay serves a very important role of educational outreach, and I am very glad that you also share this thought with us. And I am even happier that you found that the course actually was effective from that point of view. And in fact, we are very proud to have excellent institutions like College of Engineering Pune also subscribe to this effort, because when there are excellent colleges like yours also participating, many other institutes are inspired to participate. So please do continue to participate with our outreach efforts in future. I must mention to all the centers, by the way, that Professor Metkar and her team at COEP actually conducted a very interesting event in signal systems, taking inspiration from what we did at IIT. Professor Metkar, can you share your details of the event, which you conducted on 28th October in signals and systems?
Sure. Yes, sir. I would like to mention to all the centers that with the inspiration from IIT Bombay last year with the pedagogical course for signal science systems, we also have taken some initiative to conduct a kind of workshop, the application workshop of exhibition of the second year students. And we have initiated this particular, we conducted the particular workshop and exhibition 28th of October. But actually we have initiated this particular workshop 2 months when they started this semester, and we announced that yes, all the students they had to do some kind of practical implementation as some small project, whatever the theoretical knowledge they have learned in classes regarding signal science system and network synthesis. These are the two basic courses they will be learning in the second year. So we have 90 students trained for the second year. So we have made the 25 student groups we have initially formed, and each group they have find out with good applications and they try to implement the applications for signal science system and network synthesis. And it was a very great experience for all of us and for all the students also. So they have conducted and they have demonstrated that particular application of that particular specifically the small things or the small concept of single sense system and network synthesis. And all the students they have demonstrated it, and so we have conducted a full 1 day exhibition and the demonstration of this particular kind of activity and initiative. We called the faculties from other institute nearby Pune, and they came and they just judge all the particular workshop, all the exhibitions and the projects, and they again very good feedback. And all the students they have motivated that yes, whatever the theoretically they learn in the classes, the actual how we can they get the practical knowledge and practical exposure of that particular doing the things. And I think it was a very good experience for all of them also and for us also. And we all as a faculty also very proud that yes, all the students they have taken a great effort and they put their to conduct the particular workshop very successfully. And I think I just like to thank you, Professor Gadre sir also. He initiated it and he just motivated us to go forward. And this and we are sure that yes, this kind of activity will be continuing in College of Engineering Pune also, sir.
Very good. We are very happy to hear that. So, in a way, the College of Engineering Pune has been a pioneer in this effort, and I am hoping that many other institutes also follow suit or adapt that idea to their own context, because it was a very successful event, and I had the pleasure and privilege to talk to your participants towards the end of the day that day. So, that was very nice indeed. So,
it is a pride moment to all of us to be a part of this MOOC interaction and this particular activity, sir.
Thank you so much. So, we have from this is Praveen and there is a question from Professor Praveen and Professor Narendra of Shirpur. We want to know when will the students, faculty and supporting staff get the certificate. So, I think the outreach staff will get back to you. I might mention that for the faculty to get a certificate, they would have to do some work. They have to help us with some pedagogical initiative and also answer an exit survey. So, there will be an assignment given to them, for the faculty to assist in a pedagogical initiative which my PhD student is designing, Abhinav Anand. So, they will have to answer that. They will also have to answer an exit survey. That is for the faculty. Students, of course, when they pass the course, and staff, I believe the outreach staff will take care of it. So, any other center which wishes to give feedback or the Institute of Road and Transport Technology. So, the Institute of Road and Transport Technology just said hello. So, can we give them the, yeah. So, they just wrote, we saw they wrote on the messaging board, but they do not seem to be publishing the video. Bandwidth is low. Oh, yeah. Acha, it's not. Oh, you have not switched on your camera. Institute of Road and Transport Technology, you have not switched on your camera. Okay. So, any other center which wishes to interact or give any feedback? All right, if not, then let us conclude this final feedback session for the semester, conveying our gratitude and our appreciation to all of you as faculty from various centers for having participated so actively and enthusiastically in this offering of signals and systems. It is our privilege to be in some sense a first in the world, because this kind, Professor Phatak tells me that this kind of an interactive process is very rarely found in any part of the world, where you are using technology to the fullest, and in this blended MOOC or blended massive open online course form, in which there is of course a control on the offering at the local university or institute, but there is also the use of resources given by IIT Bombay, and the evaluation combines both. And most importantly, we are making the best use of technology to interact like this live, and this is probably one of the few places in the world where such a thing is happening right now. That is what Professor Pathak tells me. So, we should really be proud of it, and we should nurture this effort even further. With these words then, we conclude these live interactions and wish you all the very best for your examinations, and we hope that many of you will complete the assignments. I am talking about the faculty, the pedagogical assignment which we have given, and the exit survey, so that you earn your certificate. And similarly for the students, we do hope that they will do very well and they will complete the course with satisfactory performance. With that then we conclude the interaction today. Thank you.